let's talk about recursion. But before we start talking about recursion, let's talk about factorial. What is factorial? Because that's what we're going to try to solve for here. So factorial is, if you have some number, let's say 5, the factorial of 5 would be 5 times 4 times 3 times 2 times 1, and that will equal, if you multiply all those numbers together, that would equal 120. That's what factorial is. We're going to have a function that basically, essentially just gives the output of factorial when we give it 5, and the output's going to be 120. So 5 times 4 times 3 times 2 times 1, it's going to equal 120, and that's what this function's going to do. So this function's going to be called factorial. This function is a recursive function. What does that mean? That means that this function has a call to itself, and that makes it recursive. Basically, a function that calls itself, it's a recursive function. That's exactly what I'm showing here. So let's get into it. The first thing, a recursive function is broken down into two different sections. One section is the base case. That is, in the case that this condition is met, well, this is going to return. But basically, it's going to stop the recursion. It's not going to call itself anymore. So you need the base case, because if you don't have the base case, what will happen is you would run into an infinite loop. Basically, a call to a function that calls itself, and it keeps calling itself indefinitely. So that's not good. We don't want that. What we want is, of course, have a base case that says, hey, if this condition is met, in this case, if the number it's equal to 0 or the number is equal to 1, go ahead and return 1. Then the other part of the recursive function is the recursive case. That's the case or the section of the code that does call itself. Now, this is important too. It's important to not only call itself, but decrement it, right? Because otherwise, if you don't decrement it by 1, in this case, a factorial, it's going to keep calling itself, and that would itself return into an infinite loop as well. So you got to be careful here. So what you need to do is, again, call the function itself, but make sure that you're decrementing it, that it is changing somehow. Because if it's not changing, then you're going to get the same result all the time, and it's going to keep calling itself, it's going to keep calling itself, it's going to keep calling itself. All that to make it sort of annoying that it will be an infinite loop. So, with an overview of factorial, an overview of what a recursive function is, and its two different sections, the base case and the recursive case, let's go through this function and see exactly how does it get 120. Okay, so if we go through and we, first of all, let's run it, make sure that we do get 120, and we do see that it is 120, that we print result, and that's what we get. But here, let's just say that, when we call factorial 5, it first comes up here and says, hey, okay, is n equals to 0? No, it's not. N is not equal to 0, it's equal to 5. Or is n equal to 1? No, it's not, because n is equal to 5. So it's not going to run this. Well, it's going to run this. It's not going to execute this body of the if, because it's not meeting that condition. So it is going to run this, and we know n is 5, so 5 times factorial of 5 minus 1. Well, we know this. Python's going to know 5 times, but it doesn't know this. So 5 times factorial of 5 minus 1. Well, you know what? We're going to have to hold 5 here times, hey, Python, go ahead and figure this out, which when we run this again, we can go through and say, hey, is n equals to, by the way, let's just add this here to the stack. We know that it's 5, and then it calls, right, 5 times whatever this is. It's going to call this, so we can say times whatever this is. It's going to call itself and say, okay, is n equal to 0? No, it's equal to 4. Is n equal to 1? No, it's equal to 4. Return 1. It's not going to run. It's going to run this again. We know n at this point is 4, so 4 times whatever factorial minus factorial 4 minus 1, which is 3. Well, what is that? We don't know. Let's go figure that out. So then, since we know it's 3 now, n is not equal to 3, it's not going to run this. It's going to run this again. So we say n, which is 3 now, and we then say, okay, 3 times whatever this is, which is 3 minus 1, well, let's throw that 2 over around into this function again. N is equal to 2. It's not going to run this. It is going to run this again, and it's 2 times, well, whatever this, factorial 2 minus 1, which is 1. Let's see what what happens when we pass in 1 here. Well, if n equals to 0, no, or n equals to 1, well, it is equal to 1. It is going to return 1 and not jump into this recursive case anymore. So it's going to stop here. It's going to stop here. Why? Because n is equal to 1, return 1, and so 1 is here. Then it's going to unwind. It's going to unwind because now it does know what 1 is, right? Which was 2 minus 1. Well, it's basically going to return 1 when we call this function, so we get this. It's going to keep on winding down and say, hey, 1 times 2, it's 2. 2 times 3, it's 6. 6 times 4 is 24. And 5 times 24, it's equal to 120. Right? So that is how this unwinding happens. And when it gets to the end here, well, it had multiplied all these numbers together, and by multiplying these together, it's gonna stop the function and go ahead and return. It returns that, right? It returns the whatever the result was, which gets assigned to line 12 to this result, and that's what happens here. So I'm hoping this makes sense. In the next video, what I'll do is I'll take this and put it through the debugger so that we can see how the debugger will show us this exactly.